the entire ecosystem of big data and machine learning environment. And this is really going to set the base for us and help us understand evolution of big data and machine learning. Okay, how big data and machine learning has evolved since improvement in computing. Okay, so as we know, in last couple of decades, as the computing abilities have improved, uh, the ability of individuals and organizations to use data to extract information has improved significantly. Okay, so net, we are just going to go through this journey and get ourselves a rich understanding of what machine learning means in a big data ecosystem. Right, so here are some of our learning objectives. Okay, uh, why and what is analytics, big data, machine learning, predictive and descriptive, supervised and unsupervised learning, data types. Okay, throughout these sessions, we are going to answer these questions and we'll then try to make meaning out of the answers to enrich our understanding. So, analytics. What is analytics? So, analytics is nothing but using data to draw insight out of it and then use those insights for actionable outcomes. Okay. So, analytics is the discovery and communication of meaningful patterns in data, especially valuable in areas rich with recorded information. Analytics relies on simultaneous application of statistics and computer programming and operation research to quantify performance. Okay, so this is a basic definition of what analytics means, and you'll find this definition all over the web. Okay, and if you just go out to Google and type what analytics is, more often than not, you'll find this definition. Analytics is defined as a scientific process of transforming data into insight for making better decisions. Now, this is why we do analytics. Okay, we use data to make decisions, to improve our decision making ability. And that is precisely why we do analytics. How it is done: studying historical data, research potential trends, by analyzing the effect of certain decisions or events, by evaluating performance of a scenario. So, what we mean here by all 3 points is if we have a set of data which is collected over a period of time, we can either use it to analyze and see how and what are the patterns that emerge out of data. If we have a decision that was taken in the past or in recent past, okay, then we try to collect data around it and analyze it to see what and how, what is the impact of decision and how it has impacted the surroundings, and evaluating performance of a scenario, which essentially means the decisions that we have taken by analyzing data. Okay, how impactful they are, what is the ROI of these decisions. Okay, have they benefited any part of society, business organizations, or individuals? So this is why essentially we do analytics. Now let's go a step further, okay, back in time and try to see how data and analytics have evolved over a period of time. So this is a journey. Okay, this is the entire journey of analytics so far and into the future. Okay. Now, if you can see on the extreme left, okay, around 1975, when computers were really getting into mainstream, we started with batch reporting. Okay, so there were not too many of computers. Computers were pretty expensive with low computing ability. All that we could do with them in the absence of highly sophisticated analytics tools, maybe like something like Python or R or SAS, Tableau, all that we could do was just report the data in batches. Then we took a slight step forward towards early 80s and we started doing static reporting, then moved on to ad hoc queries around 1989 uh, with data warehousing coming into picture. We started storing large amount of data, and then online analytic processing started. Data We started building data models with introduction of some basic uh, computing abilities and tools. Then templates were designed. Then we moved on to the concept of ETL and data quality. And then from there on to balanced scorecards, collaboration, and workflow. With further enhancement and improvement in technology, the concept of dashboarding and visualization came into picture. Then the entire concept of data warehouse and lifecycle management gained momentum around mid 2005 to 6. With analytic sophistication coming into picture, there was a concept of alerting, okay, generating alerts for critical processes. And then there was this entire concept of process awareness, okay. And now the period and phase that we are going through is all about predictive analysis, event monitoring, okay, and the future is all about content analysis. Okay, so by the early 2020, we will see a lot of content analysis and event monitoring and some real-time activity happening in this space. So as journey shows, as this picture shows, as our computing ability has improved over last few decades, we have become better in storing data, in measuring, recording, and storing data, and then using the data for the purpose of analyzing, okay, generating insight and translating those insights into actionable outcomes, okay, and then storing everything as a form of knowledge. Pretty much what I've said is summed up in the sentence below the diagram. It says analytics has evolved to become the process of using quantitative methods to derive actionable insights and outcome from data. And this is what has been happening for ages. Okay, of late, maybe since maybe this has gained significant momentum. Maybe if I have to say, from my knowledge and experience, post 2000. Okay, and significant momentum since the recession that we faced around 2008 2009. Right, so let's now see how big the data is. We'll be surprised to see how data has evolved over last few years. Okay, before we get into the evolution of data, let's understand what big data is and what it is all about. And the pictures here sum it up real nice. Okay, big data is all about volume, velocity, and variety, and we're going to look at all of these individually. Okay, we are going to understand what we mean by volume of data, velocity of data, and variety, and how it really helps the data to become big, or it does not help in other ways. So volume just means the quantum of data that we are able to measure, record, and store. And the volume of data that is generated today is humongous. It is far more. I would rather say not generated, but the ability to record and store such data is humongous, and the kind of data that we are able to record and store from different kind of resources. Okay, maybe if you go a couple of decades back, we just had the ability to kind of record and store data from traditional ERP systems or hand collected census data or population data. Okay.